Let's say f of x equals 2x squared minus 3x. All right. Yesterday I think I forgot to cross off find the slope for this class, or find the equation of the tangent line. We just found the slope yesterday, and then we stopped the problem. Let's actually go through and we'll find the equation of the tangent line. Line at x equals 1. All right, we know equation and tangent line is that line that touches the curve at exactly one spot. In this particular spot at x equals 1. We don't know what y is yet. We could figure it out pretty quickly. But what are the two things we need to write the equation of a tangent line? Back in Algebra 1 days, Algebra 2 days, what are the two things you need to write an equation of a line? Slope. Okay, we need slope. So for us, for calculus, what is slope? How do we find slope? Limit as delta x goes to 0, right? F of c plus delta x minus f of c all over delta x. Okay, what's the other thing we need to write an equation of a line? Need slope and that's a specific thing I'm looking for. That's a specific thing. You need x, and you put those together, what do you get? You get a point, yeah. Oh, that's funny. Okay, so we need to find the point, and we need to find the slope to write the equation of a line, okay? So big thing for calculus is just find the slope at that one point, okay? A point, though, for us a lot of times is actually going to be x and then f of x, right? We got used to seeing it that way. Choose your own adventure. What do you want to find first, the point or the slope?
Slope.
Okay, let's do it. Okay, limit delta x goes to 0 of f of, well, we know our c value, right? It's the x value, it's the particular x value we're talking about. 1 plus delta x minus f of 1 all over delta x. Ooh, where does the y value show up? The y value is right here, right? So within finding slope, we can actually find our y value for our point. So two birds, one stone, right? Okay, so take us a couple seconds here. Find the slope, please. Like I've said probably 1,000 times, that's over-exaggerating just a little bit. That hardest thing right now is going to be the algebra. Okay, our slope, m equals limit as delta x goes to 0 of f of 1 plus delta x minus f of 1 over delta x, right? Good news is, if this is like a AP test, you might get 1 point for the setup, possibly. Okay, then it's actually time to do some work. You got to plug 1 plus delta x in. So you have 2 times 1 plus delta x squared minus 3 times 1 plus delta x. And then minus, I would get in a habit of going minus and setting up a big parentheses. Okay? And then you find f of 1. I just plug 1 into the function then. 2 times 1 squared minus 3 times 1, then n big parentheses. All over delta x. Again, now it's time to get some more work done. These quadratics are everybody's favorite. You better learn how to do it quickly. And I did forget a parentheses right here. Let me put that in there. There we go. So it'd be what, 1 squared, 2 times 1 times delta x, and then delta x squared. Notice I did not distribute my 2 just yet. Okay, no advanced moves yet. Okay, distribute -3. Don't forget to distribute to both items. And then calculate this minus whatever that answer is going to be. I leave this in parentheses because what is f of 1 now? -1, right? So that'd be my y value. Okay, we keep going. I distributed my 2 through. 2, then 4x, and then 2x squared. And then I have the rest, and I change this to a +1 then, minus negative. So now I have no more parentheses, everything combined like terms in the numerator. 2 minus 3 is -1, +1 is 0. At this point, you should not have any more constants left. Okay, the math should work out. If it doesn't, you better go back up and check your work, because this is a self-checking system basically. Okay. At this point, everything in the numerator has a factor of delta x. Factor that out. Be very careful canceling, because you're going to forget that 1 here a lot. So be very careful of that. And then we finally have this expression. We let 2 delta x goes to 0, so 2 times 0. 1 plus 0 is 1. So that'd be the slope of the tangent line at x equals 1. Is 1. Just happened to be that. Okay, so we have our slope equals 1. Our point, our x value is 1, right? Our y value actually showed up right here. This is f of 1. Or just plug 1 into the function. 2 times 1 minus 3 times 1, so 2 minus 3, -1. Okay, so there's our slope, there's our point, and we are always going to use point slope form. Okay, so remember, I'll write it again. Y minus y1 equals m times x minus x1. Okay, y goes first, so y minus -1 equals slope of 1 times x minus 1. And honestly, you can leave it like that. It would be nice if we cleaned it up a little bit. Y plus 1, 1 times x minus 1. And you wouldn't have to write this 1 as a multiplier out in front. Sometimes we like just to leave it there so we can clearly see that the slope is 1. And you guys remember what the other version, the modified version of point slope looks like? Alright, so the definition of a tangent line to a curve does not cover the possibility of vertical tangent lines happening though. Why would it not cover the possibility of vertical tangent lines happening? Because for a vertical tangent line, we know that this slope, the slope of this vertical line, is undefined, right? So you're not going to be able to solve this limit. Okay. So if it happens that this limit goes to infinity or negative infinity, then we have that vertical tangent line. Okay. So if you're solving, you get 4 over 0, it is going to be a vertical tangent line. Well, let's start working with the derivative. There you go, definition derivative. Okay, that limit that we use to define the slope of a tangent line is the exact same limit we use to find the derivative. Woo! And this is one of 2 fundamental operations we have in calculation, or calculus, differentiation. So, the derivative. And we have a new notation. The derivative of f at x. Now notice they're not giving us a number, they're just giving us x. So this is a derivative that we can use to find slope for a function for all x values. So if I give you a function, like the other day, like yesterday, I gave you a function, gave you two x values, we could have just found the derivative and then plugged those two x values in at the end instead of doing two limit process problems. Okay, so we could have done that, but we need practice. The derivative of f at x is given by f, and then it has this one little markup here. This is read as f prime of x, f prime x, f prime of x. This is prime. And that means the derivative. So f prime of x is the limit as delta x goes to 0 of f of x plus delta x. Notice we have an x here instead of a c. That means this is all slopes on the tangent line, or on the all slopes of the tangent line on the graph of f. Okay? There is another way of writing this. Limit as h goes to 0, f of x plus h minus f of x all over h. Now here's the deal. If they tell you to find the derivative, you can use either form. If you are one of those people that hates delta x, don't use delta x. Use this form now. Okay? If they start out using delta x, you have to use delta x. If they started out using h in the problem, you have to use h. Okay? Cool? But if they just say find the derivative, you can use h now. If you want to just find the slope, just use h. That's fine. And you can put the x value here if we need to. Now, this is the derivative if the limit exists. Okay? For all values of which the limit exists, f prime is actually another function now. Notice we have function notation, f prime of x. Okay? We good? Here's all the different ways we could write it. Here we go. Find the derivative. Now, I'm going to change this to f of x equals x squared plus 2x. Okay? And then the second part, we're going to do x cubed plus 2x. So let's find the derivative. Now remember, I've talked about us stating what we're going to do, and then we're going to do it. Okay? F prime of x means the derivative is equal to the limit. Ooh, we get a choice. What do you want? Delta or h? Delta it is. We'll use h next time, okay, guys? Not too bad. F of x plus delta x minus f of x all over delta x. And the why I'm using this is because didn't we just do this on a couple problems last chapter, right? You guys found derivatives already. Okay, now let's start calculating, substitute things in. And again, after we do this a couple times, we don't have to write this step out. You can just start doing things in your first step. Okay? F of x plus delta x, everywhere you see an x, plug in x plus delta x. So that would be x plus delta x squared plus 2 times x plus delta x. So this is f of x plus delta x minus f of x. So again, minus, then put a big parentheses up there. Start plugging in x. Well, f of x is just this function. X squared plus 2x. Then we have delta x in the bottom. All right, now here's the tough part, expanding and then combining like terms. Okay, expanding this binomial. X times x is x squared. X times delta x times 2. 2x delta x. Delta x squared. Plus 2x plus 2 delta x. Minus x squared minus 2x. All over delta x. Alright, so we can do, oh, looks like I got an x squared here, cancels x squared here, negative x squared, right? Looks like I got a 2x here, subtract 2x. Alright, because this is one of the first times we're doing this, let's clean this up a little bit before I start factoring. Limit delta x goes to 0. Okay, any other common things we could add together? Doesn't look like it. So I'm going to write everything out now. 2x delta x squared plus 2 delta x all over delta x. Notice everything has a common factor delta x, right? So we could have written this out factored. In the future, go ahead, just write it out factored at this step. Limit delta x goes to 0. We got our delta x up here, 2x. Okay, that would be just delta x then. If you take one factor out, ignore that. And then plus 2. In parentheses, cancel. And you get the limit as delta x goes to 0 of 2x plus delta x plus 2. I'm going to put parentheses around that because there's more than one term in the limit. Delta x goes to 0. So that goes to 0. Or we're substituting in 0. And then the derivative then would be 2x plus 2. And again, I started out by saying f prime of x equals. I'm just going to write it down here again so I remember f prime of x. You don't have to because we already have it chained nicely. Let's take this one step further. Let's write the equation of tangent line at x equals 3. Remember, we need two things to write an equation of a tangent line. We need slope at that x value, and we need the point, the x and the y. Okay, the slope is now going to be called f prime of 3. That is the slope at x equals 3. And guess what? Remember I said this is a function. This is a slope function. The derivative is the slope. In general terms, the derivative is the slope of the tangent line. Derivative is slope of the tangent line. 2 times 3 plus 2. Will that be 8? So the slope of the tangent line at x equals 3 is 8. Now I need to find f of 3, which would be the height of the function at x equals 3. Oh, what was our original function? Man, it was a long time ago. X squared plus 2x. So 3 squared plus 2 times 3. 9 plus 6, is that 15? Check my work, it's pretty early yet. Alright, write the equation. Y minus, okay, what's our y value? Right here, 15. Equals the slope, m, which is 8, times x minus